So this question involves finding the volume of a frustum using the rules for similar shapes. Now a frustum, as you should know, is basically what we call a truncated pyramid. In this case it's a cone, and the frustum is this shape here. It's almost like an upturned paper cup in a way. And what you've got is you've got a cone here, and then the top of it is taken off, leaving this shape at the bottom. So it's created by having a cone or a pyramid and removing a smaller cone or a pyramid from the top of it, leaving you the base. Now, the original cone here and the cone that you take off are similar. One is an enlargement of the other. They share the same angles up here and so on. So you can explore it and look and see that one is an enlargement of the other. So we're going to be using similar triangles. And a little bit of algebra, because this is quite a complex question. Now, the first thing we want to work out is the volume of the big cone, and then the volume of the small cone, and then we can find the difference, which will give the volume of the frustum. Now, the formulas you're going to need for this will be the volume of a cone, which is a third times the area of the base multiplied by the height. And the area of the base is a circle, so it's going to be pi r squared. So this would be a third pi r squared, and then h for the height of the cone. Now, looking at the object here, I don't know the height of this, the big cone. I just don't know it. And in fact, I don't know the height of the small one. But I do know that the difference between the two of them is 3, because that's the height of my frustum. So if I call the height of my small cone h, I now have the height of my big cone, which is just simply h plus 3. And that's going to be coming quite handy. We need to know the scale factor of the lengths. And if you look at it on our cone, the diameter of the base of the big cone is 8.8, and the diameter of the base of the little cone is 5.5. These are taken from the frustum. So we can work out our linear scale factor. So let's put that down here. So our linear scale factor is going to be 8.8 divided by 5.5, and that simplifies to 8 over 5, or 1.6. I'm going to keep with the fraction for this question. Fractions are generally more useful in similarity questions. Okay, so I have my linear scale factor, and that means that the height in the big pyramid, big cone, is 8/5 the height of the small one. So that means that this distance here, h plus 3, is 8/5 of this. So I could form an equation. So I've got h plus 3, the height of the big cone, is equal to 8/5 the height of the small cone, h. Now what I've done here is I've created an equation, and there's only one unknown, that is the letter h. One equation with one unknown can be solved, so let's work this through. First thing is subtract h from both sides. So I'm going to take h away from here, leaving me with just 3. And I'm going to take h away from 8/5 of an h. So 8/5 of an h, take away a whole h. Well, whole h is 5/5. 8/5 take away 5/5 is 3/5. So that's 3/5 h. Multiply both sides by 5, give me 15 equals 3h. Divide by 3, and h is equal to 5 centimeters. So now I know the height of my small cone. My height of small cone is 5, and the height of my big cone is going to be 8. Now that's going to be useful because now I can work out the volumes of the shapes. The volume, as you know, is involving the radius and the height. The radiuses I can get from halving the diameters of the bases. So the radius of the large one is just half of 8.8, which is going to be 4.4. That's my radius. And the radius of this one is half of 5.5, which is 2.75. I have the radiuses, I have the heights, so I can work out my volumes. We'll need some more space for this, so we'll have a nice clean screen here. So the volume we will do first is the large cone. So the volume of the big one, or the volume of the large one. And that is equal to 1/3 multiplied by pi multiplied by the radius, which in this case is 4.4, and that's squared, multiplied by the height, which is 8. If you put that into a calculator, you will get the answer of 162.19 and a few other bits, and so on. Try and keep the entire number in your calculator, or keep it in terms of pi. And then the volume of the small one is going to be 1/3 multiplied by pi multiplied by the radius of the small one, which is 2.75, and that's squared, multiplied by the height of the small one, which is 5. Work that out and you get the answer of 39.5972 and a few other things. Again, leave the whole number in your calculator if you can, or leave it in terms of pi. Certainly don't round it to less than 2 decimal places at this stage. And then the volume of the frustum is just the difference between the two. So it's 162.19 subtract 39.5972, and that gives me an answer of 122.5928, which rounds to 122.6 to 1 decimal place, and that's centimeters cubed. And that's the question done. We have the volume of our frustum, the piece at the bottom there. So all of these questions kind of follow a similar sort of pattern. It's usually the big cone taken with the small cone giving you the frustum. Sometimes you have to work in reverse. Go through the different steps of this, making sure you fully understand. Try and do it with the calculator as well, with rounding your answers that are on the screen now, and also using in terms of pi. And just see how that slightly alters your answer. But as long as you're within the bounds of the answer on the mark scheme, this will probably be 122.6 something, then you'll be fine.